We've got a pretty newish red Blues Junior here. Repair ticket says breaks up too soon, about half power available, new Mesa tubes currently. So let's see what's going on with this thing. Let's remove the rear panel. I can do this faster. Actually, let me show you the way I usually do this. I was trying to do it all clear for the video. I back them out a little bit to make sure there's no obstruction in low speed mode. And since these are machine screws, I can then go to high speed. Go a little bit faster. Low torque at all times. This tube cage here, I kind of hate it. It rattles a lot, but I'm not going to unilaterally remove it from the client's amp. Now, before I try to pull this panel out, I want to explain again, for those who missed it in previous videos on the subject, that on the Blues series, the Hot Rod series, whether it's a great big Hot Rod DeVille or a Blues Deluxe or a Blues Junior, this is not the only thing holding this rear panel on. There are screws on the side here, one on each side, which compress the wood into the metal chassis. And so before removing the rear panel, I like to back those off just a little bit. You can see the whole thing flex and release. Do it on the other side. Just, a 1/16 of an inch. You can hear it there. You can see it move. And once that's the case, the rear panel comes out easily. There may be a little adhesive strip up here. That's not a big deal. But if you do that while it's compressed and you force it, they break right here on this one. On the bigger amps, they have two of these vents and the very narrow portions of wood on the side, and that's where they break. So I'm running now into that tube. When did it come out all the way? There we go. So push these screws back in, set it to the side so we don't have anything go missing. And let's look in here. So we've got the IC brand filter caps, no visible leak. I'm looking at the condition of the resistors and the tubes. And there's been some fugly work on the phase inverter in the past, with some cut traces that I don't understand. Oh, damn it. That means I'm gonna have to pull this board to see what's going on with that, because that should not have been cut. That's on the grid of each side, pins 2 and 7. So something fugly is happening underneath this board, and I can't see it without pulling this board. And it's not that I don't want to work on this, though, compared to all the vintage amps I've got and the ones I'm building, this is not my favorite thing to work on. But it is someone's amp, and I treat that with respect. But in this case, having to pull this board increases the cost of the repair. Let me move the camera so you can see what I'm seeing. Right in here, there's a component lead poking out here at the plate. There's a component lead poking out and bent over at the grid. Same at the cathode. Some cut traces. A lot of flux. So on both sides of this tube socket, someone's been in there. And I have worked on an awful lot of these and never felt the need to do anything there. In fact, if I had done this, if I needed to replace components in here, I would have done it from the top side for heat reasons. But it means before I do anything else, well, normally I'd say before I do anything else, I need to pull this board, but let's see what it sounds like and see if that gives us any clues to what's happening. Yeah, that's not a good sound. That's not a good sound for this amp at all. So early breakup. It doesn't have low volume though. Very thin though. So before, again, I'm probably gonna have to pull that board, but let's just tube roll just a little bit, see if we can save the guy some money. All right, the amp sounds awful. So let's just power it off. Actually, let me show you a trick while I've got it here. I'll power it back on and get some good volume. This is a quick and dirty way to discharge tubes. And I'm not saying this is the best way to do it, and I assume no liability if you do this and get zapped. But all right, so I got the amp on a pretty healthy volume for this thing. Power it off at the wall. And just play until there's no more sound, and then play a little bit more. I powered it off at a receptacle. You can just also unplug it from the wall. And that means that all the DC stored in the filter caps drains out. It has no AC coming in. There's no DC with which to replenish it, so they just drain out. So let me measure what little DC is remaining on those filter caps. And if there is a filter cap with a lot of DC present, that tells me there's a bad solder joint. And we'll see what's going on. Now that's sound coupled with the lack of a large current draw from the amp tells me that none of these caps are shorted. But if one of them is opened up or is just gone to almost no capacitance, then one of the nodes will have no filtering. You can have that kind of ugly sound that we've got. All right, I got 7 volts on the reservoir, 7 volts on the screen, 7 volts on the phase inverter, 7 volts on the preamp. So now that I only have 7 volts to play with, I'll just do this. Don't do this unless you really know what you're doing. If you do this with high voltage present, you can arc and take a chunk out of your screwdriver or take a chunk out of a component. But now that 7 volts should magically be 0.2 volts. So much better. All right, now the amp is safe for me to work on. I've got mine still plugged into the receptacle, but I have the receptacle powered off. So I know that this is safe for me to touch anything in the amp at this point. Again, don't do this yourself. All right, the next thing I want to do is see what might have gone wrong in the amp. They've got some diodes and screen grid resistors here. They use little 100 ohm, half watt screen grids in this series. And that's really inadequate, and sometimes they get messed up. 97.8, 98.1, 1.5, 1.5. So these are okay. Underpowered though they may be. So let me measure now on the phase inverter from pin 1 to pin 6. They'll tell me if there's a problem with the connectivity. 200K, that's good. Now let's do the same thing. Well, the cathode should measure the same, pin 3 to pin 8. That measures the same, so there's seemingly the conductivity is good. Let's see on that stuff. Well, I suspect that they've added something else in there. It's possible that there's something in there that's not up to drawing the current, even though it measures okay cold. So it will be time to pull this board in a little bit. Let's see how quickly we can do that. I don't know if I can do the repair today. I might have to order some parts, but let's see what we're up against. By the way, I hate these tube retainers and Boost Juniors. They fall out. Oh, there it goes. And they're really hard to put back in place. Very finicky design. And I'll tell you the truth, they're not actually needed when these sockets are new. But I'm going to take it out now so it doesn't fall and get lost. And the other spring, all right. This is easier to do when the chassis is out of the amp, but that adds to the cost. So with Blues Juniors and the like, I try at all times to keep the cost minimal for the owner, because it may be their baby, but it is an inexpensive baby, and it's hard to justify a big repair bill on these things. I guess you can't really see what I'm doing. Let me lower this a little bit for those playing the home game. Always use a socket to loosen nuts. Wrenches invariably screw things up. No possible pun intended there. And this one here with the plastic nose often gets a little bit bound up on the compression it goes through. They really should not have used a plastic nose jack. Feels like the nut wasn't quite on straight to begin with at the factory. No, it's at an angle. That's why it's so slow. I'll take a look at this, make sure the threads aren't all chewed up as a result. Only takes one sloppy assembler to mess things up. I hate plastic nose jacks. I kind of hate this style of switchcraft jack anyway. It's has no mechanical strength on the contacts. Can't get a grip. So this is the speaker jack here and the foot switch jack here. Let me get these lock washers out of the way. Yeah, the threads are a little bit boogered, not too bad. I should be able to put that back on straight. While I have it here, I make sure all the connections look solid. All the solder joints there look good. All right, next I've got a whole lot of screws to remove from the bottom here. And because of the height of the cabinet, I can't fit my power screwdriver in, so it's time to do this by hand. I need to get a right angle attachment for my power screwdriver. Let's see if I can fit this. Nope, can't even fit that in. Time to go to the stubby. Oh, it's not a number 2, it's a number 1. Let's see if I can fit my number 1 in there. Yes, okay, good. Okay, all the screws are out. Now before I just start flipping this up and tearing around, I want to point out that these connections are these ribbon cables to this board, and the connections to the ribbon cable to the PCB board, to the tube socket board, are very fragile. You have to be kind of conscious of that, and no sudden movements, no herky jerks. All right, this is very strange here. I was expecting components on this side of the phase inverter because they were there. You know, the other side of this has got such weird, ugly work. Let me flip this up very carefully to show you, and we're going to figure out what's going on with this tube socket. And this might be the problem in a nutshell. I think what's happening here, let me get this closer. Maybe someone tried some kind of mod here. Maybe someone tried a Bill-M thing and just got it all wrong. The phase inverter does not usually burn traces. There's just not a lot of current. But this trace is cut and this trace is disintegrated. And if we don't have a good connection on all this, it can go haywire. I'm going to pause this and move the camera because I can't do all this with the way this is oriented with the camera. I'm gonna get all the old solder off except for the heaters, and we're gonna see what's happening underneath the fugly. All right, I got all the old solder off and most of the flux. Got a little bit more to go. And the pads are just burned off, and the traces are all boogered up. So these will be cutting in and out. And this is not the kind of heat damage that you get from the tube. This is someone using the wrong soldering iron temperature. And they reflowed some points on these output tube sockets, and where they reflowed it, they boogered it all up. So I'm going to get all this old yucky solder out and see what condition this pad is. This pad here is gone, but fortunately this is pin 8 on the EL84, which is not in use. The ones I need to verify on the EL84 are pins 2, 3, 4, 5, 7, and 9. If any of these are bad, then only half the output's going to be working, which can lead to distortion, but would also lead to a lower output. The same thing can happen if only half the phase inverter is working. Now the sad thing about this is that with these PCB mounted sockets, and these are quite good Beltons on these later boards, these connections are what physically hold the tube in place. And since the tech mangled these 6, there are only 3 that still hold the socket in place, which means that there's not a lot of mechanical support for this. And because the way these boards were done and the chassis were done, there are very large mounting holes in the chassis because the tube actually feeds through. It's over 1 inch, whereas the typical chassis would have 3/4 inch opening here, in which case I could just put in a new tube socket, chassis mounted. Now, I've got a friend who makes replacement output boards for the Blues Junior. Higher quality board, everything done right. And if necessary, I can order one. But given that a 12AX7 does not weigh an awful lot, I'm going to see if I can get this to mechanically work first, to see if I can get this, electronically work. And if necessary, because if it fails after this point, this board has to be replaced. Once I make sure that it is electronically working, I can get in here with some E3000 or whatever and goop this, maybe even some epoxy. All right, I've got all the yuck and old bad solder off these 3 sockets. This is the phase inverter. These are the 2 EL84s. And the pad here for this cathode on this EL84 had lifted up from the trace, was separated from the trace, had a big blob of yucky bad solder on it, covering it. Couldn't see that. So it looked like it was soldered. It wasn't. This cathode is lifting. All these pads are wanting to lift. The factory pads are not lifting, so it wasn't heat from operation of the amp. It was some tech using the wrong temperature iron, or too large a tip, or just adding solder to it and using the wrong kind of solder. And this has made what would have been a simple repair, whatever the original issue was, into this great big mess that I've got to try to fix. And a couple of thoughts here. Number one, because of this poor work before, it's a lot more work for me to undo this. I've got to go in here and remove coatings from traces and try to reinforce things, or order a replacement board from my friend who makes a higher quality replacement board for Blues Juniors. And I will give all these options and estimates of costs to the owner. And if he approves the work or approves the replacement, we'll resume this repair. He may walk away from it at this point, at which point I charge an $80 diagnostic fee. And if he doesn't approve that, I get a greenback out of it. If he approves it, he gets his amp back. He can put the greenback in something else, or have a Blues Junior full of spare parts. But because whoever did this work did such poor work, this is going to be a fairly expensive repair when it should not have been. Now, on that note, I've had people ask, why'd you charge blah, blah, blah when it's only a $300 amp or a $400 amp? The price of the amp has nothing to do with the price of repair. In fact, in general, the cheaper or less expensive the amplifier, the more repair costs. This has a lot of screws to remove to access things. I've got to pull boards to access things. It was built very fragilely to begin with. It takes a lot of work to do this right. If you don't do it right, you end up in a worse state like you are here. So, I just had a buddy drop off his 64 Princeton reverb because the reverb started making noise. And I opened it up while we were talking. He was only here about 15 minutes. I opened it up, I pulled the chassis, I went in there. Oh, he had a dirty reverb pot, and the reverb pot was a little bit loose on the chassis. Took off the knob, tightened the pot, gave it a squirt of deoxit, gave it a squirt of fader lube, tested it, sounded great. He went on his way, happy with a 64 Deluxe reverb. Total time of service, 15 minutes. I didn't even charge him. He can buy me a beer next time we hang out, now that we can start hanging out with people again. This is not a 15-minute repair. So I understand the good musician's frustration, but it is not my fault that you have an inexpensive amplifier that requires a lot of time to service. If you want it fixed, I can fix it. I will explain all these things to the owner. I'll share this video with the owner. And I'm not saying that it's a bad amp or that anyone who owns a Blues Junior has made a mistake, or there's no judgment. I'm sure there are people making great music with these all over the place, but they have common weaknesses. And when someone goes in here and does this kind of work, it makes those weaknesses potentially fatal flaws. So let's see what the owner says and where we're at on this, and see if this is something that needs to go farther, or needs to have a new board, or it's time to replace the amp.